Okay, example 1. Yesterday they gave us one function and they told us to find the inverse of that function. Well, today they're going to give us two functions and we're going to figure out if those two functions are inverses of each other. Okay, so first let's write down the two functions. Okay, so they're giving you two functions and you have to decide, are they inverses of each other? Okay, well to figure that out, you have to take the inverse, or find the inverse of one of them. We learned how to do that yesterday. Which one of these functions would you like to find the inverse of? Okay, so if we're looking at that first one and we want to find the inverse of it, what is the first step of finding an inverse? Switch the x and y. Well, where is the y? The h of x. So I'm going to rewrite it quickly as y equals negative 4 plus 3 over 2x. And then I'm going to do step 1, which says switch the x and y. So it'll be x equals negative 4 plus 3 over 2y. Yes. Now, step 1 is switch the x and y. Step 2 is, well, step 2 is solve for y, and so what would we do first? Add the 4. Over here it'll cancel because negative 4 plus 4 is 0. When we add 4 to x, you can't actually combine them because they're not like terms. So it will stay x plus 4 equals, not yet, 3 over 2y. Okay, now what do we do to get y by itself? Okay, isn't y being multiplied by 3 over 2? So normally when you're multiplying to undo it, don't you divide? But we don't like to divide by a fraction, so what can we do instead of dividing by 3/2? Keep, flip, change, or keep, change, flip, however you want to say it. We keep this one, but instead of dividing by it, we change it to multiplication and we have to flip it. So you multiply by the reciprocal. And the reason you do that is because, look, when you multiply that by 2/3, these 2's cancel out and these 3's cancel each other out, leaving y by itself like we wanted. But you also have to multiply this other side by 2/3. And now, what do we need to do over here? Distribute. What is 2/3 times x?
2/3 x.
And what is 2/3 times 4? Well, I know it's positive because they're both positive, but what's 2 over 3 times 4? 8 over 3. Okay, so the inverse of negative 4 plus 3 over 2x is 2/3 x plus 8/3. Does that look familiar? Look. Doesn't that look just like the other function?
Yes.
So that means, yes, they are inverses of each other. Because when we found the inverse of one, it was the other function.
That's cool.
Now, I'll give you a second to copy that, and then we're going to example 2. Alright, example 2. G of x equals negative x plus 3. F of x equals negative x plus 3. Okay, it's the same function. We need to see if they are inverses of each other. To see if two functions are inverses of each other, you find the inverse of one of them. Which one do you want to find the inverse of? Does it really matter? It's the same thing. So, we change g of x to y. And now the first step for finding the inverse is to do what? switch the x and the y. So what will that look like? Okay, what's step 2 for finding an inverse? Solve for y, so we'd start by subtracting that 3, canceling it over here, subtracting it over there. That leaves us with x minus 3 equals negative y. Now have we solved for y?
Divide.
Right, this is a negative 1 that's being multiplied by y, so to undo that, you divide by negative 1. Okay, now yesterday I was just writing divided by negative 1, but I feel like kids were getting confused by that, so maybe it will be easier for you if you divide both of these by negative 1 individually. Then you can see it. So look, cancel, y equals, what is beside this x? What is 1 divided by negative 1? Negative 1, right? So this is a negative 1x, and you don't really have to write the 1. And then what is negative 3 over negative 1? Positive 3. Does that look like the other function? Yes, it's the same as the other function. So yes, these are inverses. Okay, example 3. Example 3, f of x equals 12 minus x over 4. G of x equals negative x plus 1. And we want to find out, are they inverses of each other? Well, to find that out, you have to find the inverse of one of them. Which one do you want to find the inverse of? Okay, the bottom one. So instead of g of x equals, we'll say y equals negative x plus 1. Now to find the inverse of that, what do I do? Switch the x and the y. So what will it look like once I've done that? X equals negative y plus 1. And then after you do that, what do? Subtract 1. Over here, 1 minus 1 cancels. Over here, it just becomes x minus 1. You can't actually combine them. Equals negative y. Now is y by itself? No, why not? There's a negative 1 beside it that we need to divide by. Those cancel, because negative 1 divided by negative 1 is just 1, and you don't have to write a 1 beside the y. Then you divide this by negative 1 and this by negative 1. Okay, isn't there also an understood 1 right there? So what's 1 divided by negative 1? So negative 1x. You don't really have to write the 1. And then what's negative 1 divided by negative 1? Positive 1. Now, does that look like the other function? So no, these are not inverses, because when you found the inverse of one of them, it did not look like the other function. The answer, the inverse was that, negative x plus 1. So basically, you got the same thing as the function. The inverse matches the function, but we were wanting it to match the other function, and it didn't. Okay, example 4. I'm going to write it down, and then I'm going to let you try it by yourself first before I go over it. F of x equals 2 minus 1/4 x. G of x equals negative 4x plus 8. Okay, I want you to figure out if those are inverses of each other. Okay, which one do you want to find the inverse of? The top one? Bottom one? Okay, so the first thing I'm going to do is, instead of g of x equals, I'm going to write it as y equals. Since step 1 is switch the x and the y, I kind of need an x and a y to switch. So x equals negative 4y plus 8. Step 2 is solve for y. So what would we do?
Minus 8.
Correct. Subtract that 8. Now we have x minus 8 equals negative 4y. Now what do I do? Divide by the negative 4. Over here it cancels and just leaves y by itself like we wanted. When I divide that by negative 4, isn't there a 1 there? So that's negative 1/4 x. When I divide that by negative 4, what is negative 8 over negative 4? What's a negative divided by a negative? And what's 8 divided by 4? So positive 2. Does that look like the other function? Yeah, even though it's a little bit different, you still have the same thing. You have a positive 2, positive 2. Negative 1/4 x, negative 1/4 x. It's still the same thing, even though they're flip-flopped. Just think about it. Can't you add in any order? Okay, so this one is, yes, it is, they are inverses of each other. Okay, now what I'm going to do before you do your classwork is I'm going to go back through each of the 4 examples and I'm going to show you a shortcut method. Okay, but I needed to teach you this method because you needed practice finding the inverse, because you will have to know how to find the inverse to do the test. Okay, so now I'm going to teach you the shortcut method for finding out if they're inverses of each other. Okay, Diana, pick a number.
4.
5.
Okay, pick a function, h or f. Okay, so if we take the h function and plug 5 into it, won't it be negative 4 plus 3 over 2, but instead of the x, she chose to plug in a 5? Go ahead and calculate that. Everybody calculate that. Okay, and y'all got 7 over 2? Okay, so now what you're going to do is you're going to take that 7 over 2 and plug it in the other function, the f function. So f of 7 over 2 will equal 2/3 times 7 over 2 plus 8/3. See how I'm just rewriting that function, but in place of x, I'm putting 7 over 2? Because that's what I got when I plugged in 5.
Yep, that's right.
And what did we get?
5.
Isn't that what we plugged in initially?
5.
So it confirms that they are inverses. Okay?
Why didn't we
Now, would that work if you don't work it out?
Let's try it with example 2. Okay, what number do y'all want to use?
8.
Okay, what function? Okay, so f of 8. Okay, negative, but in place of x, we're putting an 8 plus 3. What is negative 8 plus 3? Okay, we then take that negative 5 and plug it in the g function. So that'll be a negative 5 plus 3. And y'all all understand why I got negative 5?
Yeah.
Okay, what do you get?
8.
Isn't that what we plugged in? So that confirms that yes, they are inverses of each other. Okay, now let's try it with example 3. What number do y'all want to use?
6.
And what function? G, okay. So g of 6 would be negative 6 plus 1. What is negative 6 plus 1? Negative 5. We then plug negative 5 into the f function, so that'll be 12. Look, minus is already there, and then in the place of x, we put the negative 5, and then over 4. So what is 12 minus the negative 5? And what's 17 divided by 4? Right, it doesn't reduce. You could make it a mixed number if you want, but regardless, is that what we plugged in originally? No, so that's why these are not inverses. Okay, so now use the plug-in method yourself with example 4. Just try the plug-in method on your own. Any number. Okay, somebody give me your number that you plugged in.
2.
2, okay, and what function?
6.
Okay, so g of 2 would be negative 4, but in the place of x, we're inputting a 2 plus 8. What do you get? 0. Then you take that and plug it in the f function, which would be 2 minus 1/4 times 0, and that gives you 2, which is what you plugged in originally. So yes, they are inverses. Okay, everybody understand? All right, now you're going to work all problems on page 25. Okay, don't forget what's coming up. Tomorrow, we're learning the last topic of Unit 2. Thursday, we're taking the 10 square, and we're going over the test review sheet, which you're going to get today to take home to start working on. And then Friday is the test. The 10 square is over pages 10 through 25. So if you finish this worksheet early today, you might want to look over 10 through 25 to make sure you've got all the problems finished on those pages.